Today we will solve the problem 4.15 of Griffith third edition Introduction to Quantum Mechanics. Problem 4.1 is first we will solve section A. Find the expectation value of R and the expectation value of R squared for an electron in the ground state of hydrogen. Express your answer in terms of Bohr radius. The hydrogen atom wave function is psi 1 ground state energy. For ground state energy, n is equal to 1 and Lm00 psi 100 is equal to 1 over square root of pi a cube e power minus r over a. Now we have to find the expectation value of r and r square. So what I am going to do is I am going to find the expectation value of r power n, so that I can easily generalize this for r and r square. So by definition it is equal to r power n modulus psi squared t3r, which is equal to, if you square this wave function, modulus psi squared is 1 over pi a cube and it is exponential term. Of course I have taken rn, and we have to replace the t3r in spherical polar coordinate system. T3r is equal to r squared sine theta t theta t pi tr. So now this integral will become into 3 integral. Remember that this is not minus infinite to zero, infinite. It is 0 to infinite. Because it's a spherically symmetry, we are taking r from 0 to infinite. Now you separate this integral into three parts. One is with respect to t pi, with between the limit pi varies from 0 to 2 pi. So if you differentiate and apply the limit, if you integrate and apply the limit, you will get 2 pi. And similarly, if you integrate second one with respect to theta, between the limit 0 to pi, you will get just you will get 2. So totally you will get 4 pi. So these two integral is 4 pi, first two integral with respect to theta and pi. This pi and this pi will get cancelled. You will get 4 in the numerator. So this can be written as 4 over a cube integral between 0 to infinite or n plus 2. I forgot to mention this. See, here you have Rn and here you have r square. If you combine both, you will get Rn plus 2 e power minus Rn plus 1 e power minus 2r a. So now first two integral we have solved. So this will simply become 4 over a cube integral between 0 to infinite r power n plus 2 e power minus 2r over a. We will further integrate. We have to integrate with respect to r only now. Now we got this integral, that is expectation value of r power n is equal to 4 over a cube integral between 0 to infinite r power n plus 1 e power minus 2 r over a t r. We have to integrate with respect to r. We have already seen the integral using Feynman technique, that x power n e power minus alpha x tx is equal to n factorial divided by alpha n plus 1. Here you can see the n is replaced by n plus 1. So this will become n plus 1 factorial, n plus 1 factorial over this 1 over alpha n plus 1. N is n plus 2. So this will become n plus 2 plus 1, n plus 3. Here you have 2 over alpha, sorry, 2 over a. So this will become, alpha will become a over 2, then n plus 3 by 2. Sorry, n plus 3, because alpha is here 2 by a. If we take it into denominator, then it will become a by 2. So this is a by 2 n plus 3, n plus 2 factorial. Because here n factorial, n is equal to n plus 2 here, so this is n plus 2 factorial. Then what is the expectation value of R? Now you can find the expectation value of R and R squared using this generalized formula. Here you put n equal to 1. Then this will be 1 plus 3, 4. A divided by 2 power 4. And this n plus 1. N is 1. 1 plus 2 is 3. 3 factorial you will get. Now you can reduce this. This will become 4 by a cube. This is a power cube divided by 16. That is 2 power 4 is 16. 3 factorial is 6. So we can cancel some of the term. This a cube will get cancelled with this a power 4. Just it will become a. And here this will get cancelled with this 16. 4 will get cancelled with 16, which will become 4. Then 6 by 4 is 3 by 2. So this will become 3 by 2 times a. So this is the expectation value of R is 3 by 2 a, where a is port radius. Similarly, what is R expectation value of R squared? Here you put n equal to 2. So this will become 2 plus 3, 5. A by 2 power whole power 5. And this is 2 plus 2, 4 factorial. So you will get 4 over a cube, and this will become a5. A power 5 divided by 2 power 5 is 32, and 4 factorial is 24. Here you can cancel some of the term. This will become a square. This is a square, and this will become 3 into 3 times 8. So 3 8 is 24, and 4 8 is 42. So this will become 354, and naturally this 4 and this 4 will get cancelled. You will get only 3a squared. So 3a squared. So the expectation value of R squared is 3a squared, where a squared is the 4 radiations. So we have calculated part A. Then we will move on. Section P is find x expectation value of x and x squared. Here we know that R squared is equal to x squared plus y squared plus z squared, and exploit the symmetry of the ground state. So the ground state wave function psi 100 is equal to, we have already seen, 1 over square root of pi a q e power minus r over a. Here the expectation value of x is x multiplied by modulus psi squared T3R. Here just by a look we can say this will be 0, because modulus psi squared is even function, x is add. So add integrand between the limit minus infinite to plus infinite, you will naturally get 0. But we will do it in a formal way. This integral we can separate into 3 parts. And this x, remember that this x in terms of spherical polar coordinate, this will become r theta cos pi, r sin theta cos pi. then this term you will get as it is, that is modulus I square, and TQR, T3R is equal to R squared sin theta T theta T pi TRQ. So now you can group the same parameter, that is first x modulus I square. You can see here you have one cos pi, here you have one cos pi, and you have t pi. So first you have to integrate between 0 to 2 pi cos pi t pi. Then next here you have sin theta, here sin theta, you will get sin square theta t theta between limit to 0 to pi. Then next r integral. First you come to this. If you integrate this, naturally you will get cos theta will become sin theta. So sin 0 0, sin 2 pi also 0. So you are going to multiply all this integral by 0. Naturally, the expectation value of x is equal to 0. Now, we know that the expectation value of r squared is equal to the expectation value of x squared plus the expectation value of y squared plus the expectation value of z squared. Due to symmetry, we can take expectation value of y squared and z squared as expectation value of x squared. So this will become 3 times the expectation value of x squared. So if you bring this 3 to the other side, then the expectation value of x squared is equal to 1 over 3 expectation value of r squared. Just now we have seen the expectation value of r squared is equal to 3a squared. Now here this 3 and 3 will get cancelled. So you will get simply a squared. The expectation value of x squared is equal to a squared. Now find the expectation value of x squared in state n equal to 2, L equal to 1 and m equal to 1. Earlier case we have seen the for ground state, that is where n equal to 1, L and m are 0. Here it is first excited state. So we will see the expectation value of x squared for the first excited state. So this will be equal to, by definition, x squared modulus psi squared T3R. So as usual, this can be written as R, x can be written as we have done earlier, x is equal to R sin theta cos pi. So if you square it, you will get r squared, x squared, you replace x squared by this one. Then you will get r squared sin squared theta cos squared pi, then modulus psi 211 squared, then T3Q is, you know very well, this is r squared sin theta t theta t pi t r. And the first excited state wave function psi 211 is equal to 1 over square root of pi by a 1 over 8a squared r e power minus r 2a sin theta e power I theta. For this, please refer my lecture uh, on problem 2.3. Sorry, 4.13. So this will be equal to this. Now you square this. If you square this and take it out, 1 over pi a and 1 over, if you square 8a square, this will become 64 a power 4, and you separate this into 3-part integral. So now you can see this integral will become, here you have one cos pi. First you take the cos term. Here you have cos squared pi, and here you have t pi. So cos squared pi, first integral is 0 to 2 pi. cos squared pi t pi. Then next you take sin squared, sin theta terms. This is sin squared and this is sin squared theta, and this is again one sin theta is there. So this will become sin power 5 theta t theta between the integral between the limit 0 to pi. Then next one you take r. You have here r square, here one r square, here another r square, which will become r power 6 and this exponential term e power minus r over a tr. Now we have to calculate this integral. We have three parts, then we will solve one by one. This integral consists of three parts. That is integral first pi, integral with respect to pi, then integral with respect to theta, and integral with respect to tr. First we will take this integral with respect to theta. Is slightly lengthy, not actually lengthy, it is slightly lengthy. Then you can calculate I of theta, integral due to this theta term, which can be written as 1 minus cos squared theta whole squared. The idea is this is 1 minus cos squared theta is equal to sin squared theta. Sin squared theta square is sin power 4 theta, and we have multiplying by sin theta. So this actually here we are replacing this by sin theta power 4 into sin theta. So this sin theta power sin power 4 theta we are writing as 1 minus cos squared theta whole square sin theta t theta. Now what I am going to do is I am going to take u as cos theta. Then what is tu? Tu, if you differentiate the cos theta, you will get minus sin theta t theta. So you replace this. Here I am replacing this as u squared because cos theta is u. This will be u squared. Remember that whole square you have to take. Then what is this? This is minus tu. That's what I have written. That is 1 minus u whole squared multiplied by minus tu. So now we have to change the limit of the integral also. If you change the limit of the integral, when cos equal to 0, cos 0 is 1. Then cos pi, you change the limit pi, cos pi is minus 1. This integral is between the limit 1 minus 1. So I am interchanging this limit. I am changing because here there is one minus is sitting here. So to remove this minus, I am changing this as from minus 1 to plus 1. That also I am going to change, multiply by 2, 0 to 1. Remember that after changing the limit, I am multiplying by 2 because I have changed the limit 0 to 1, and now you take the square of this one, 1 minus u squared whole square, which is equal to 1 plus a squared plus b squared. B squared is u power 4 minus 2ab, that is minus 2u squared tu. If you differentiate first one, you will get simply tu, integral tu is u, and next one u power 5 divided by 5. Third one is minus 2 u 3 u power 3 divided by 3 between the limit 0 to 1. So you can ignore the lower limit because it is 0. You apply only the upper limit. First term will become 1. Second term will become 1 over 5. Third term will become 2 over 3. Now you can take 15 as LCM. So this will become 15 plus 3 minus 10. So you have 2 also here. So after simplification, this will be 3. Numerator will become 3. This term will become 18. Uh, this term numerator will be 18. 15, 8. 15 plus 3, 18. 18 minus 10 is 8. Divided by 15. Here already there is 2 here. Uh, there is 2. 2 into 8 is 16. So this will become 16 over 15. This is the theta integral. Then we have to find pi integral and r integral. And now we will carry out the pi integral. So I pi is equal to integral 0 to 2 pi cos squared pi t pi. So this cos squared pi t pi can be written as of 1 plus cos 2 pi. T pi, of course we are integrating with respect to pi. Now this will become two integral. One is t pi with respect to t pi. If you carry out the first one, you will get to pi, and limit if you apply 0 to 2 pi, you will get 2 pi. Then what about this second one? Second one, for first one you are getting 2 pi. The second one, if you integrate cos theta, you will get sin theta. For sin 0, 0, sin 2 pi also 0. This will be 0. So the totally this integral will be 2 pi, and you have 1 over 2 outside. So this 2 and this 2 will get cancelled. You will get simply pi. So this integral is equal to pi. Then we will come to the r integral. So which is equal to integral between 0 to infinite r power 6 e power minus r over a t r. You can use payment technique. So if it is in this form, you will get n factorial divided by alpha n plus 1. So here n is 6. So that means you will get 7 factorial multiplied by 1 over alpha n plus 1. So n is 6, alpha is 1 over a, 6 plus 1 7. So this will become a power 7. 7 factorial a power 7. 7 factorial is 720, and this a power 7. Now you combine all three integral. So you have 1 over 64 5 a power 5 you have outside the integral. Then this is equal to this pi integral. With respect to pi is you have pi. You can see this pi, and this theta sine power 5 theta is equal to 16 divided by 15, and r theta, this value is 720 multiplied by a power 7. Now we can simplify some of the terms, constants. You will get this pi will get cancelled first, and this a power 6 will get cancelled with a power 7, which will become a square. Then if you divide this and this, uh, that is 4 into 16 is 64. So 4 into 16. So you will get to 4 into 15. If you simplify 720 into 60, then you will get 12. So this will become 12a squared. This is the expectation value of x squared for a first excited state of hydrogen atom, where a is 4 radius. So we have calculated this also. Thank you very much for watching my video and supporting me continuously. Thank you very much.